All right, it's 9 o'clock my time. It's much later in the day in Europe. Welcome to our webinar today. This is going to be called Building Enterprise Production Ready Agentic AI, a co-production of Grid Dynamics and Temporal. We're going to teach you how to go from MVP to production with observability and guardrails. This is going to be a 45-minute webinar. We have an open Q&A panel running throughout the webinar. We also have some polls running throughout, so please do feel free to engage. Hopefully, we'll be able to get to everyone's questions at the end, and a recording will be sent out to all registrants afterwards. So if you have to miss something, don't worry about it, but please do send some questions along if you have anything at all you want to ask us. I'm Alex Garnett. I am a developer advocate at Temporal, working on a few of our AI initiatives, as well as our teaching, our docs, our workshops, and everything in between. And joining me is Simon from Grid Dynamics.
Hello, everyone. Thank you, Alex, for the integration. Thank you, Temporal team, for the initiative. Nice to meet you all. I'm Simon, and I'm from Grid Dynamics. I'm an AI and data solution architect, working with several AI projects and data related. In the last year, especially, we started to discover Temporal, and the result was amazing. Like everyone likes it in my team, including myself, and I'm so happy to be here.
Thanks, Simon. So today we're going to cover the AI explosion, all the recent growth in AI projects, including MCP, different generative implementations, everything in between that you might want to implement on your end. We're going to talk about the platform challenges with shipping AI projects, all the scalability and reliability questions that you might have while you're embarking on your AI journey. We're going to talk about the problems with MVPs that don't necessarily scale very well. And we're going to talk about what enterprises need to be able to ship robust, reliable, durable AI solutions in production. So, to start out, the AI explosion. If you talk to just about anyone in any software company right now, every department is running their own AI pilot. I don't think this is an exaggeration at all. I was doing some client meetings in New York last week, and every single one of those, they brought up that there were one or two people in their office running a little skunkworks team who were trying to implement their own chatbot for working with their documentation or some other internal service offering, or trying to ship something to their customer base. Every department is currently running a pilot and trying to figure out how to get to production with an MC project or something else along those lines. The platform teams are usually playing catch up in this case because you have a lot of scalability and reliability questions to address when you are trying to ship a brand new interface, especially if it has to communicate with a large commercial LLM provider that can have its own downtime, its own non-deterministic behavior, and present other state tracking problems that you have to address on your end. A lot of the big LLM offerings, they're not exactly complete end-to-end products. They're powerful API endpoints. They're extremely sophisticated in terms of what they can do, but they haven't done the work to get to a product that you can then turn around and ship, either internally or externally. And it's really hard to get visibility, observability, any of these hooks that you need for robustness to hook into these AI platforms. You're starting from scratch a lot of the time. Governance is usually not that far along, and costs are going up all the time, right? Everyone's used to having an AWS bill that sort of gradually ticks upwards. This is like that on a whole new scale. And so there are a lot of novel challenges people are facing. So there are problems to solve. A lot of these projects are running without oversight because companies aren't sure how much to invest. They're not sure if they have the means to spin off a whole AI project team in some cases. And so you have these projects just kind of running along in the background of an org that don't really have enough ops attention. And it's hard to scale your ops at the best of times. There's cost chaos. Bills can scale very quickly, especially if you want to change which model you're running dynamically and cut around to a few different models in production. Spending can grow very quickly. This leads to a lot of well understood and well established problems. You wind up spending a lot of your time fighting fires and not necessarily scaling your successes. It's one thing to have an AI endpoint that works some of the time and returns a response, but to go from it returns a response to we can actually use this and rely on it and operationalize it, and it has the kind of reliability that the rest of our stack has, is a big, big leap for many teams. And this presents gaps in governance and security. Saying nothing of the fact that LLM behavior can be non-deterministic on its own, and it cannot be used for all inputs in most orgs, you have to figure out how you're handling this. You want to have insight into what your teammates are sending to and from LLMs, and you want to be able to get good data back from what your customers are doing with them. You want to be able to see what questions are being asked. You want to be able to gather all that data. You need a way to hook in and to build all of that out. So the platform challenge.
Well, I will jump in here because personally affected us as product developers, and what especially is what made us firefighting, as you introduced before, Alex. No, so imagine here we have like an ambitious AI project. So what everyone starts to do is always like, okay, I start from my own laptop. I connect to OpenAI. I do my first prototype. I say, oh, cool, it works, right? So in this moment, you think that you have a powerful, responsive, and intelligent process. But a lot of scenarios are not really ready to be applied to everyone. So you don't have certain controls around, like, for example, safeguards, as we mentioned here, or some enterprise or some company related rules. Or it can even happen that you don't know how many people are going to actually use that platform. Imagine like in scenarios like Google with VO, where you are generating tons of videos, or you want to have a PDF generator for projects or plans and so on. And then like 1 million users start to use it. It can happen multiple times that what happened on your laptop doesn't scale enough to be ready for multiple audiences, or at the same time you are going to create tons of silos, prototypes that at the end of the day will be developed with different styles, different models, different tokens and parameters. So here is where actually the combination with Temporal made us arrive at a certain level where we said, like, guys, here you have set of parameters. You have here, especially with integration with OpenAI Agents SDK, that on one side you have the configuration, and then it doesn't really matter how you want to use your agents. You just need to configure it, and everything gets dispatched. So in this way, you have the possibility to just trigger your agents and then just wait there. It can be that the video generation will take 1 hour or 5 minutes or whatever. You just stay there. So here is where actually you have a big boundary between having the agent running or the LLM running and losing their control. Yeah. So here is where I connected that MVP, right? Don't scale. So here we have the scenario with our application running in our laptop or in AWS Lambdas or in Azure Container Services. How can you be sure that in one moment that the CPU goes overhead or a network is going down or OpenAI decides like, oh, sorry, we have some downtime, you didn't lose 1 hour of text generation? On your laptop, you say, okay, that's totally fine. But what if it happened for a big organization and then boom, landing 1 million loss? Here is where enterprise needs, first of all, reliability, resilience of the process, but at the same time, governance and customization. So you need to perform something that you are sure that even if OpenAI or Gemini or your local LLM, because you want to run maybe an open source, at the startup, after a specific downtime, still has that answer that was generated and you paid for 1 hour earlier. Or you want to have a tool call that perform a non-revertible operation. What will you do? You need to spend hours and hours in thinking, how can I make the prompt in order to be sure that if I run this tool again, will skip it. Or if I say, like in one of our scenarios, migrate code, generate business tasks, Jira cards, and so on, is not landing in a Jira board nightmare where you have 350 tasks that have been duplicated across different boards because maybe one letter was different. These are scenarios that when you do POCs are not considering. But if you start with, for example, temporal workers and workflows from the development phase, in that case, you can see already that the same pipelines will stay up and running without having issues on downtimes, network issues. Maybe you're working from a train and you're losing the connection in the middle of nowhere. So yeah, here is where the AI needs to be resilient. Regarding the platform challenge, I wanted to leave it for the last step before moving forward. That is actually what Alex introduced, that is the guardrails. So what are you, how often are you verifying that your LLM is actually producing what it's supposed to do? So we, on Temporal, we are orchestrating the agent, right? So where we are developing it, we are giving parameters, setups, but where actually the developer jump in, where the leader jump in is on all the organization standpoint, all the rules, the guardrails, the observability, the operation part. So here is where with Grid Dynamics, mostly we have the time spent in defining the platform itself, not the agent orchestration, but the platform. So when we go at the client and say like, okay, here is the platform. We can put Temporal, we can put Airflow, we can put everything, but you need to have this platform understandable, readable, extendable, and so on. So, and first of all, secure. The main topic about AI was always, is it secure? It's not going to drop my prod database. Well, it might. If you use it unresponsibly, it might. It actually happened, and there was this big boom on Reddit about the guy that said, oh, I tried with Cursor, and boom, my prod DB was gone, right? So here is where the platform needs an helper, a backbone that, as we mentioned, is temporal, but all around is where using, for example, OpenAI, Guardrails, or Langfuse for monitoring and tracing, Guardrails, and so on, you can basically have something that is a white paper, but at the same time is easy to read, even for non-technical people, and define where every agent can go and stay until the task is done. Okay, so sorry, I was taking a breath. So here, as mentioned, orchestration is critical, right? So we need to have the task that is always queryable. For who is familiar with temporal features, you have state, retries, and workflows. I will leave Alex going over these two tasks, and I got a bit confused. I'm sorry.
Oh, it's okay. Thank you, Simon, for that great introduction. We at Temporal were really excited to witness the AI boom because As we say, every product in AI that is not like a machine learning, high performance GPU cluster problem is basically an orchestration problem. And orchestration problems are all problems that Temporal is already solving. This is a category of work that some people refer to as ML ops. And this is everything Simon was just talking about, state tracking, making sure that you're persisting your input and outputs from your LLM somewhere that is not the LLM, right? Ideally, you want to be able to treat the LLM as stateless, and you can retain state on the temporal side and take that out of the equation. So that way you don't introduce new reliability concerns that you wouldn't have with any other third-party integration. Temporal handles retries for you. Temporal lets you model all of your code as an end-to-end workflow that will take several atomic steps while it's going through that workflow. And from any one of those atomic steps, whether it's a tool call or a validation step or anything else that you would expect as a turn-taking interaction with an LLM, we can retry from any one of those states and we can track state internally so that there are no reliability concerns introduced. And we can even do fun tricks in the back end, like cut over between LLMs sometimes. That way, if you're experiencing downtime from one, the customer wouldn't even notice. LLMs alone can be brittle. Like I said, these are not really meant to be complete, robust product offerings just yet, right? Like there's a lot of work you have to do on top of most commercial LLMs to introduce reliability and to make them real products and to do all that additional input and output validation and figure out if you have an MCP implementation, which tools you want to be able to call at different times. So we help take you from, yes, I have an LLM to, okay, I have a product. And that product meets my customer expectations and it meets my own internal needs. We've recently announced the OpenAI Agents SDK, which works with Temporal, and that helps you get all the way to enterprise scaffolding without having to do a lot of additional work, right? It's as close as we've gotten with Temporal to saying, okay, it's not just an orchestrator, now it's a framework. And we're really excited about that because it takes a lot of the questions for early building off the table, and you already have all of those reliability concerns addressed at the very start of the project.
And here is actually what surprised me a lot about the integration, right? And I mentioned already some of the topics of this slide before because it's really interesting for me now that we are trying to create agents workflows or LLM workflows, AI workflows using Temporal to, I don't need to write majority of my code, right? So that's a great feature that Temporal's team put in the community and especially on the GitHub repo and easy to use. So here we mentioned like observability first. Why we have it as a first point? Because you want a lot of scenarios happen where it's like, oh, the LLM worked and then suddenly didn't. So especially when you use tools and MCP servers, you're giving basically a huge Swiss knife with 1 million of tools. And you're saying to the agent, I'm pretty sure you can figure out, right? You can just understand, like think like a human and then say like, okay, go ahead and do something. But as we know, LLMs are not deterministic, right? And that's why you need also the LLM call to be resilient in most of the cases. And this is why the observability at the end of the day become crucial because you can potentially go back in time and check, oh, with this specific prompt or with this specific series of executions, it didn't work well. So here is where in the overall architecture that we'll show later, the observability, the interception of the activities becomes almost the core need, almost the first step that you put in the transition between MVPs and the product that Alex mentioned before. So Guardrails observability, and unified platforms are the three key points to have the product. So observability gives you the all details, right, on step by step, how much it's costing to you. And the other point connected to the platform is how much I'm saving potentially, right? Because if you start to use OpenAgents SDK or any other framework on a simple Kubernetes pod, and you start to iterate through the same prompt over and over again, you will see that your costs will start to like skyrocketing, right? While if you say, oh, wait, let me retrigger just this task, or let me go back and take everything from this workflow and start it again from the middle line, you will see that you can try and try and try different combinations at half of the cost. And combination of these two, observability, resilience, and retriability of the tasks, allow us to deliver a product that even in 1 year, you will be able to say like, oh, I saved X thousand dollars that can be reinvested in your company, not in firefighting, troubleshooting, and midnight calls with some technical support that has to jump in and get also like extra hours payments, right? So here is the main backbone, actually that backbone of the platform. And the other part is you can make a puzzle, right? So you don't need to use one of the products I mentioned, or you have to host it only on AWS just because Alex mentioned it like 10 minutes ago. I said, oh, he said it, so maybe I had to use it, right? So you have a series of blocks that you can deliver and then just focus on the development. For example, Guardrails, right? You are a finance organization. You can just keep the same blueprint that we are developing in Grid Dynamics, right? This blueprint, I say like AI platform. It's just the name is generic because this is how the blueprint looks like at the end of the day. And you just need to change the rules that are built for your business. You are in retail, so you know that you have SKUs or you have some specific items that can be sold only in Brazil region or in European regions. And the combination of these two will make your platform just be like as easy as possible to just edit and extend. This is why I mention all the time platform.
Yeah. Thank you, Simon. And so we've got a bit here just on temporal best practices for those who might not already be familiar. I'm looking at the poll respondents and I can see that 60% of you are already working with temporal on your agentic AI journey. So that's fantastic. But I'll just go over some of the things we like to point out when we're talking about temporal's advantages, benefits, and how we help get you there. So, for example, with temporal, you can start with guardrails and observability on day one. By hooking into all of those steps that your workflows will run, you have the ability to always add additional calls that do not introduce any additional brittleness or any additional complexity into your code base. You already have all those events being persisted out into whatever you're using for Grafana observability, Datadog, anything like that. You can just push it right out. I think we talked about Phoenix, Simon, a little bit. So you have those hooks pre-existing. Every single step that your workflow takes, Temporal lets you turn that into a node in your charts. You can use your workflows for any kind of failure handling, for retries, for any long-running tasks. And when we say long-running tasks, we basically mean any task that's not going to return automatically once you execute it. So for any conversations that are still open or still outstanding, you can use a temporal feature called signal with start so you can reopen conversations and things like that. We give you a lot of tools to make sure that you're not using resources when you don't intend to, and so that you can parallelize very, very, very far and run a lot of concurrent sessions without it introducing any additional reliability concerns. We give you everything you need just to scale horizontally. And that way, when you do have users creating additional sessions with your AI, that doesn't cause any new concerns. You can standardize your orchestration across teams. We provide a lot of Helm charts, and we have some new worker versioning features coming that you might have heard about, which are actually providing some new Kubernetes deployments and automatic scaling for temporal workers. So look forward to that. And you can treat your AI like any mission critical system by giving it first class ops and scaling it the way you would any other part of your stack. I love to show this slide because this slide points out what your AI architecture might look like without temporal. When I give this talk at conferences, one thing I always say is that any distributed system just turns into building queues on top of queues on top of queues. You spend all of your time architecting and engineering different kinds of queues, and you start thinking about whether you can have, eventually consistent databases and figure out how you do task scaling and task distribution and how you have your ingress set up and all this stuff. Like, how do I make sure I don't lose any messages? How do I gracefully abandon chats that have expired? How do I persist into my database? These are all questions that will come up that you will have to figure out how to scale and how to distribute on your own without adopting a framework like Temporal, which sits right in the middle of that chart and handles all those queues, handles all that worker scaling, handles all that persistence, handles all that task roll up. All those questions that would come up otherwise and say, how do I clean this up? It's just basically like killing my database as soon as I try to scale anything. We sit right in the middle of your stack and we help address all those scaling questions, all those workflow management questions. So what's the impact? Well, Temporal helps you accelerate development. You can focus on just the business logic. This is one of my favorite Temporal features. Instead of spending all of your time coding around edge cases and coding around potential error scenarios, your failures don't have to take up all your time. It doesn't have to be, like an 80-20 problem where your golden path is the old thing that doesn't get any attention because everything else is a not so golden path. We facilitate quick prototyping with our CLI server that's built into our command line client, so you can do development on your own laptop. And we have a web UI that provides a lot of opportunities for debugging and introspection that many of you have probably seen before. This lets you reach greater scale more quickly. You can get to production, handle more customers. Like Simon said, you'll sleep better at night. The likelihood of having to get paged because of some system outage goes way, way down because we give you a lot of built-in automatic failure recovery. We get you distributed systems automatically, right? You don't have to figure out how to scale after the fact. You have the scale baked in at the beginning, and it just becomes elastic as you go. We offer this framework, and it's built on top of the best orchestrator in the business. You get all these reliability features, and you just have to kind of scale it as you need it, as you go. And this makes your customers way, way happier. They trust your agentic application to be reliable and correct. Trust is a big issue in AI systems, right? Like you don't want to introduce an AI that can run the wrong tools or that can have uptime issues. And out of the box, those are questions everybody will face. So we're really happy to offer a solution that resolves that at the start of any project.
All right. Thanks, Alex. I think we can move directly to the next one. I will connect this to the next slide. So, as mentioned before, unified orchestration, right? So, as Alex showed in his diagrams before, temporal is in the middle, and this one is potentially our platform. So, this is a blueprint of, as you can see, pretty small in terms of components that deliver a fully functionable LLM or agentic solution. So you have on the right side observability with instrumentation, interceptors, sessions. And on the left side, what you need is just tools and LLMs. So here on top of that, you can have UIs, you can have queues, you can have background tasks. And what happens is that everything will just flow through Temporal that will take care of guardrails, cost, security, trigger using OpenAI Agents SDK, trigger guardrails, inbound and outbound, right? And at the end, what you need to do is just, you're developing the pilot project, you're developing a phase one, and you just need to put it in your Kubernetes cluster or in your container registry and make it available. Maybe you're on-prem, you want to run it on your own VM, who matters, right? So you just take your repository with your worker definition, use the scalability feature for the workers, and just be sure that your UI is up and running, right? So at the end of the day, for the customer, is transparent, right? What they see is just an entry point. They don't need to know what is on the back, but at the same time, they will never see a potential failure. Even though they are asking something that your organization perhaps does not allow, it will be just a response and say like, oh, we tried multiple times. We even thought that maybe you were thinking about something else. Maybe you meant something else. And at the end of the day, what you see is just like after 10 seconds, 30 seconds, just give you the answer back. And here, everything is done from the back door. There will be a person that in his 9 to 5 work say like, oh, let me check yesterday. I see that there is like $2 more in my LLM calls, right? So you just need to check on the back and say, okay, apparently here the agent didn't work so well because someone asked about IT 696 products instead of asking about 897, and this person was connected from France and was supposed to ask it for UK. So everything goes from the domain application, right? Not from, oh, I see like 65,000 stack traces that have been triggered in my Datadog or in Grafana with a lot of alerts sent via email. This will not be visible because it actually didn't happen, right? So it can be that even during the night, Gemini went down and we had to reroute through OpenAI or through our backup Llama 4 that was developed on premises, deployed on premises, for the customer would be completely invisible, especially that OpenAI Agents SDK, Temporal SDK support Let LLM, right? So it will be easier also to dispatch to different models and say like, oh, if you tried 2 times to Gemini, reroute to the other one, or maybe you have a dispatcher on the back. So here, if you go to the next slide, Alex, you can see how the workflow looks like, right? Okay, here we were happy like that. It was everything successful. But this one is an example of giving us a task to convert an old school, old but gold COBOL project to something more modern like Python. Now, we're not saying that Python is modern. It started really long time ago, but it's at least it's still used nowadays, right? And here you can see the combination between invoking the model activity, invoking MCP tools, add other tools that maybe you have as activities in Temporal and want to make it part of your agent. At the end of the day, you have a series of executions. Let's say that the model, okay, I will create a new private GitHub named Python merge sort that we see in the middle of the screen. Failed. Binary, maybe GitHub was down. At the end, we are using an external system, right? In that case, what happened? It will wait, it will retry, and knowing that GitHub is a big corporation, most probably they don't want to have a downtime for like 1 hour or more, no? It would be like 10 minutes. Your application didn't go crazy and say like, oh, alert, alert, alert. No, just waited. Boom, continue. The day after you wake up, say like, oh, did my agent finish to migrate my merge sort COBOL algorithm to Python? And it will be done.
You know what I can do right here? I can actually show off the Temporal Web UI because I kicked off a OpenAI research workflow earlier, and it looks just like you showed. This is using the deep research OpenAI SDK offering. And so what we're doing is we run several different model activities. These all send different search strings. So Caribbean vacation costs, April adventure tourism, and it'll run several different queries along these lines in parallel. So you can help parallelize all the activities that your workflow is running. And then at the end, it will run one more activity to help combine and concatenate all the results. And if we look, you can see the timeline that all took place on, and you can also see all the different steps that were logged over the course of that workflow. So you see all these different activity tasks that were dispatched while we were querying the OpenAI API, and I can just kick it off once more so you can see it running in real time. So I'll just run one more of these while we have it real quick. And here we have brand new workflow, and we're going to be invoking some model activities again. And all of a sudden, that first activity tells us we want to run several more activities in parallel. These are all pending right now, so you can see Temporal's ability to handle many parallel activities. And these are all running on their first attempt. Some of these start to resolve, so you can see in real time how it's handling communication with a third-party API endpoint. We have one more model activity. That's going to be able to resolve. That's going to use all of the individual inputs from each of these. And once that last activity resolves, our workflow is going to get marked as complete. And that will be the end of our LLM interaction in a tidy 45 seconds or so. So this is a really short canned example, just with a specific search string baked in. But all this code is available in our Python samples repo under the OpenAI subdirectory. And we'll show links to that at the end of this webinar. And back to you, Simon.
Sure. So here is I wanted to just leave like a small section on the human in the loop, because you mentioned before the signals, the query part of Temporal, and why not integrating with agents, right? At the end, you need to submit tasks, but maybe after some time you just leave. Your Temporal workflow might have been gone in timeout or just finished the lifespan, no? So you want to come back, or the agent failed. Maybe it's like, okay, like I eat some misbehavior, and it's like, oh, I apologize for repeated failures. So here, let's assume that maybe your workflow completed, right? So here is the power of workflows in these scenarios, because I just need to send a message back, and can be the same workflow ID, can be the same workflow. Maybe you want to keep it up and running, because anyway, Temporal will keep like the pool clean, no? So I don't need to keep my resources always up and running. And you can engage more the customer to either give feedback on your behavior, but at the same time to be sure that the chat or the actions that they're doing together are related to the same workflow. Why this one is crucial? If we step to the next slide, you can see the observability part. So here we have request responses, checks in the middle, checks in the handoffs between agents, right? So it can be that in the middle of somewhere, the workflow had some downtime, or maybe, as we said, GitHub was down, or Gemini was down. So at the end, the MCP servers can generate errors, even like one missing parameter, or your tool maybe failed because of your DB that is down. So in this case, what happened? You can see and say, oh, here I see an error. And the customer didn't notice it. So at the end of the workflow, they even give me the like on the answer. But here I can see that the error was connected to my GitHub down, or the error was related to the PDF generator that I have as a microservice in another Kubernetes cluster. So here is the guardrails for the input. So we can assume that the user is asking a question. Is a development task. So this is a feature of OpenAgents SDK. But still, as you can see here, is invoking a sub-agent. What if the sub-agent is not available at that time? So it's waiting there, it's keeping them up, and then say, okay, okay, I checked. It's actually a coding task. Let me move forward. Let me generate the code. And at the end of the day, what happens is that you just finish your task, come back, and say, like, okay, now it's time to check the output. And we can see in the next slide how much it becomes critical in this case. Here we have a big squad, like 6 agents, one with each responsibility: coding generator, business analyst, project planner, architect, a GitHub manager, or known as DevOps engineer, right? So all of them are supposed to do something specific. But what if, while we are mixing all the tools, all the capacities of our GitHub server, it's like, oh, something failed in between. And at the end, in the scope of the task, only 70% is done. The output still needs to return to the user, but the guardrails will be triggered and say, like, oh, wait. Here you forgot to update your issues on GitHub, or you forgot to finish the review. So here is where using Langfuse or Grafana with Prometheus or Phoenix, as mentioned before, you can trigger and track all the activities that have been done that on the application side will never be visible. And yeah, just to close it up, for non-technical people, what if your manager come and say, like, or the CTO come and say, like, oh, we spent $100,000 only on LLM calls this month? You have to find a quick place where you can see and say, like, well, this was like last month when we were developing using this model, and this model. But the application has this series of steps that cost X, another one cost Y, and you need to have this visible for non-technical people, because logs are only for developers. Non-technical people want plots, diagrams, right? So this is why to say that the platform is complete, an AI platform is fully shippable to production, needs to have the monitoring dashboards.
And that pretty much concludes our regular program here. So, in summary, if you want to stop your firefighting pilots and start building resilient, governed systems, use temporal and grid dynamics. Learn how to accelerate your readiness today. These QR codes point to grid dynamics, and they also point to our OpenAI Agents SDK with the temporal integration. So, follow up on any of those if you like. And if you want to see the code samples I showed off earlier, again, those are in our Python samples repo, and I'll add a link to that in the chat as well. And I think we have some time for Q&A, Hannah. Is that correct?
Yes, we do. So we have 2 questions as of now. The first is from Ed saying, we are using temporal Java implementation. Does temporal provide reference architecture using Java dependencies and not Python?
That is a great question. Thank you for asking that. So, I'll get the bad news out of the way first. We do not currently have a reference AI architecture in Java. That is because when we did a survey of all the existing AI platform offerings, almost everybody offers a Python and generally a TypeScript SDK. We do not see a lot of AI implementations across other projects in languages other than those two. But Temporal handles multilingual code bases really, really well. One of my favorite things to talk about our SDKs is that they're a really nice native idiomatic. Our Java SDK has a lot of Spring Boot patterns. And because all of our SDKs just use protobufs and gRPC, You can have the AI orchestrator part of your code base written in Python and just have it run alongside the rest of your code base in Java. And Temporal makes that integration very straightforward. So if you're interested in contributing a Java AI architecture, guess what? We have a code exchange right here on this slide, and we would love to see some patterns if you are building out an LLM interaction in Java. If not, I think you'll find our multilingual support very useful.
Great. Thank you very much. We also have a question in the chat. Is temporal compatible with LangGraph? It's been challenging with the deterministic nature of temporal.
Just trying to find where this question is written down. I think you might have just moved it out of the chat. So you said, is it compatible
Yes.
with Lang? Yeah.
Yes. Andrew's asking, is temporal compatible with LangGraph?
Yeah. So I would say we're compatible with anything. We are an orchestrator. We are a very powerful generic orchestrator. And you can look at the temporal documentation to see how we use signals and queries and other ways of implementing interaction with external systems. Temporal goes really, really generic. And actually, this OpenAI Agents SDK is the first time that we're trying to go a bit narrower and provide a more specific framework. So you might find that if you want to use Temporal with LangGraph alongside, you'll be using more of our generic features, and you should have enough tools to do that.
Great. Thank you very much. Someone else is asking, our agent workflows require daily updates at the moment. We're using OpenPipes, RT Agent, and LangGraph to execute workflow tasks via MCP and search. We use dspy and a lightweight prompt handler, to define the workflow. Guardrails are built into the prompt handler. I don't like this. It's over-engineered, in my opinion. We want to move away from this convoluted setup. Does Temporal support the ability to update workflows? And that is in the Q&A if that's too long to for me talking.
It sure does. We have our versioning APIs that you might want to look at. I mentioned our new worker versioning feature that lets you basically hot patch any of your running workflows and add different branching logic to them that you can use conditionally. So that way you can update workflows that have already been launched or already in progress, and you can have them take different routes based on the input they receive if you want to revise them in place.
Great, thank you. And then someone else is asking, when creating an agent, I want to try different models from different providers to choose the best one for my scenario. However, this means I have to adapt the output of the providers for each case, which is time consuming. How do you handle this scenario? Do you use some external library or house solutions?
Yeah, so as we know, all models behave differently, and most of them also behave non-deterministically. So you'll sometimes get different output from the same input and be like, oh great, what did I become an engineer for in the first place? And so this is why we have guardrails and we have validation steps. And the nice thing about temporal, like we've been speaking to, is that you can always add additional checks after every given LLM interaction. Usually you're going to have one or two validation steps that do something else, right? And so as far as temporal is concerned, those are all activities, those are all external calls. You can make them as reliable and as complex as you need by just adding additional activity calls to validate your responses.
Thank you. Okay, last one in the Q&A as of now. Since Temporal is a fire and forget system, how do you handle a UI as a client which expects a request/response pattern?
Ah, great question. So I mentioned workflows that run indefinitely, that don't return automatically a little bit earlier on. And what I meant by that is that it's perfectly natural for a temporal workflow to block and wait for input. If you look at our docs, the section that's called message passing or message handling, we use temporal primitives called signals, queries, and updates. So that way you can have a temporal workflow wait for input from some front end or some other external system, and it can then communicate back with the front end by using queries or updates to refresh every time, for example, it takes a turn talking with a chatbot or something like that. So temporal, it's a fire and forget system in the sense that you hopefully won't get paged at night if you have tasks that are running on a schedule, and we can help handle automatic retries. But we have lots of ways of blocking and waiting for input and designing it around UI paradigm.
Amazing. Thank you very much, Simon. Alex, anything else you want to say before we let everybody go? Awesome. Well, thank you both so much. Thank you everyone for joining, and we will have the recording out with the deck in the next few days. If you have any other questions that weren't answered, that we may have missed accidentally, you can go to our Slack community. That will also be in the email follow-up. Thank you very much.